Hello and welcome to this webinar on how to improve your BIM projects with the new Cype 3D, power, speed, and renewed 3D modeling. My name is Sonsoles. I'm a civil engineer from the Technical Support Department here in Cype, and I'm very excited to share with you all the new latest features of one of our key softwares, which is Cype 3D. With Cype 3D, you can design and analyze 3D structures as well as their foundations using footings, spile caps, trap beams, tie beams, and also this software carries out the analysis of fire resistance, and we can also size bolted and welded connections. The number of improvements this software has experienced in the past few versions have taken it to a whole other level. So that's why we like to call it the new Cype 3D. Please feel free to comment on the chat. We'll be answering all your questions enough during the webinar. Shortly after it, stay tuned till the end of the webinar. And without further ado, let's take a look at the software. So this is the new Cype 3D, in which you can now display the 3D representation of the elements. Here is a look of the 3D representation of the elements. For those of you who already know Cype 3D, you can tell that the interface, the user's interface has changed a little bit. We now have this on the left side, this dockable window environment in which we will find some windows that can very much be adapted or your necessities. But what I mean by this is that you can take any of these windows and place them wherever you want them on the screen. For example, these view options could be displayed here in the bottom part of the screen, or if I take out this tags window, I can place it on the right side on the screen, or we could even choose to hide them and just close them to have this work area completely visible. In this work area, we can not only display the 3D structure, we can also open 2D view windows of this structure and come back to the previous configuration whenever we want to. By clicking here on window, we come here to reset the window layer, and all of this dockable window environment will be reset. There is one window that doesn't open by default, and we will have to come to this window to actually click on properties and select. If we want to have these properties, which is very useful and we'll be using it throughout the webinar, we can very easily place it here right by the tags window, and so that way we can access it later. So this dockable window environment, what can we find in it? The first window that we find is actually tags. Tags is the new name and functioning for the layers. So besides assigning colors to the elements, we can also, as we already did, if we click on this first column, we can select the representation if we want to see them in bar node kind of representation, or if we want to actually see the 3D. In this second column, what we can do is actually hide the elements. So we can make visible whichever we want to at whichever time, just like this. And the third column is, to me, the most useful of all, because you can unlock and lock the tags so they are not snappable. In this case, I have all these tags locked, and if I unlock the columns, we can click here on bar and describe, and if we select by with a rectangle, you will be only snapping the bars that are actually attached to the column tag. So this is very helpful. As you can see, we could describe this column as rolled steel section, timber section, extruded aluminum. We also have, and we'll see it in example, we have reinforced concrete elements and also composite sections. So further into the window, we can click here to either represent using the color layers or not. If we unclick, we will see it all displayed in one color. And another part of the window, which is the view options, allows us, if the model is actually represented with using the bar and node representation, we can display the text over the elements. So how is it done? We can come here in this bar and node model and come to the display text on the elements. And now you can see that each element has its own text according to the section of each bar. So these texts can actually be they're sizable. The scale can be switched. For example, if we want to display them smaller, we can by setting here the scale. Or if we also want to scale the nodes for maybe more comfort in the modeling, we can also do that by clicking here on the dimensions, and we will be doing exactly that. For example, I can make the nodes bigger to make easier its snap, and come back to the size where it is comfortable for us to take a look at the structure. So yeah, this work area, this now dockable window environment. And so we have other new features which are actually related to the analysis. As you know, the software carries out the analysis according to many codes and standards, which you can choose here in the general data of the project. For concrete, for steel, you can choose between European codes, the US standard, all the codes that are actually implemented in the program. You can access them or check them by coming here to Cype.com. You will find here in our website, when you come to solutions, and if you click on design codes implemented, you will have a list of all the standards that this software is actually adapted to. So filtering by software and choosing your country, you will know exactly if we have your code implemented or not. Another one of the new features is actually displaying the force diagrams over the bars with infill. So whenever we have a bar or a shell model, if we come here to the analysis tab, we will find some of the results, such as these displacements, the reactions that could be shown on screen. We could even display the form shape of the building according to whichever load case, and even play an animation on how this structure deforms. But what I was speaking of is the diagram forces over the bars. So let me come back to the 3D representation mode, and we are going to actually unlock the bottom chord of these trusses. So this tag is actually bottom chord. I'm going to unlock it to now come to analysis, forces, and when we come to here to the property window that we placed earlier here. We can select bars only in consult values. It, for example, display the axial force over the bars. And if we, as we have the tag bottom chord selected, we can display the um, diagram force over the bars. And even if we want to, we can even display their values. Maybe if we go to the 2D view of this, we can better see them. And of course, we can adjust again the scale of the text at any given time. So those are some of the features related to this new user's interface. But we have actually in this 2025 version also implemented hardware acceleration. So if we open this bigger job, this bigger structure, we can see how it takes no time to refresh the model. This hardware acceleration that we have implemented in this version, what it actually does is it smoothens the movement throughout the model. So at any time, if we zoom or we rotate the view, it takes no time to refresh the model at all. Also, this hardware acceleration, what it allows us is to snap really quickly all the elements. For example, I have left unlocked the vertical webs of these now trusses. And if we come here to bar and describe, we can see that it selects the bars very, very quickly. Another new feature would be coming here and actually selecting that we don't want to highlight the snapped elements whilst selecting. So that's up to you whether you want to see them highlighted or you want to not see them highlighted. You can do that. Okay, so another one of the new features would be there's the ones related to the surface loads. So previously, when we moved a panel, the surface loads didn't adjust. Now they do. Okay, if we change the geometry of a panel that contains surface loads, these surface loads will adapt to the new geometry, as well as the new tool for dividing the panels, which is going to make this job much easier. For that, we're going to open this portal frame generator. This is this This workflow is very typical from one of our softwares to the other, from, in this case, from Portal Frame Generator to Cype 3D. In Portal Frame Generator, we can easily generate the geometry of a warehouse-like structure, and it's wind loads automatically. So we can then export it to Cype 3D and prove these new features. So here in portal frame, we're going to generate a new geometry. We're going to generate a new frame. It's going to be dual pitched and it's going to have this geometry is fine. So when we come to general data, and we actually, the number of spans is going to be 5. The distance between the frames is going to also be 5. If we click that we have roof and lateral wall cladding, we can come to this wind load. And actually, this software will generate the wind loads automatically according to the code, the standard that we choose. We can adjust some parameters, but basically, it will generate those loads automatically for us. So without further ado, if we click here on export and we select what exportation options we want, we can now click accept. And this will open a new window inside 3D for that geometry. So we can click here on accept, and we click accept again, and we create this new this new job here in Cype 3D with the geometry that we imported. So the bars are not yet described. We can do this here in bar describe. We could actually assign one of the previous sections that we took a look at. Maybe this IP 200 would be enough. And if we click accept and complete the model with a few, maybe let's do it with the 3D representation of the model since it's new, we can easily complete the model by adding a few more bars. And what I want to show you is that the loads have come from the portal frame generator. So you can here see that we have wind loads, and those wind loads are actually distributed to the bars using panels. So here we come to load, and this new feature, divide panels, is as easy as this. We can choose through which points we want to divide the panel, and it has done it very, very quickly. Now, to change the geometry, I'm going to insert 2 more bars. Right here, for example, and right here. And we're now going to move the panels, and the loads are going to be adjusted to the new geometry. So if we come here to load and move panels, we can choose this part of the panel. And if we choose the vertices and click on the right click, we can now take it to this other position, and it's as easy as this. So we select this other one and the 2 vertices, and we move it right here. And this other panel also could be moved to this other position. So as you can here see, the surfaces, the um, wind, wind load surfaces have adapted with the panel. This is very helpful when the geometry only changes a little bit. If the modification of the geometry is important, maybe because the values of the loads do not adjust, they only adjust in geometry. If the geometry of the warehouse changes much, we will have to repeat from portal frame generator. Okay, so let's move to other. What else is new in Cype 3D? So I said before that the number and the importance of the improvements that this software has experienced in the past few versions is incredible. And it's mostly due to the implementation of OpenSys. OpenSys is an analysis engine for linear and nonlinear analysis. It was developed at the University of California at Berkeley, and its use is worldwide spread to simulate the seismic behavior of structures. So it's a standard approach for the projects. Using this standardized analysis engine, you're guaranteeing that your projects are more standard. So 2 very important last test features. We had them in previous versions. Actually, 2024 version already has some of them. Is actually the backlink analysis and the nonlinear analysis. So these 2 operate with this OpenSys analysis engine, and for the backlink analysis, basically we do a linear backlink analysis. We solve the eigenvalue problem using the stiffness matrices and the geometric stiffness matrix for an applied load, actually obtaining the critical load factor for each backlink mode. As we know, the critical backlink load, the one that would make the backline of the structure can be also calculated as this. So using these two formulas, the software is able to assign the coefficient, the backline coefficient to the bars automatically. So we run this backline analysis, and after it, you can automatically let the software choose the backline coefficient for the bars. Also, the influence of backline mode on the bar can be measured using the participation percentage. Basically, the bar that absorbs the highest deformation energy for one mode would be the 100% participation, and all the other bars deformation energy, the participation percentage can be obtained dividing their deformation energy compared to the maximum deformation of that other bar. So to show you this with an example, let's maybe close some of these previous jobs. And here we're going to, here in File and Recent Files, I'm going to actually select this model of this footbridge. Okay, so this footbridge art, it would be otherwise very hard to obtain the length, the backline length and the backline coefficient. So we are going to run the backline analysis to obtain them. And very briefly, if I chose that only these bars, the arc and the actual bracings of the arc intervene in the backline analysis. Whenever this arc is compressed for any combination, it's most likely going to buckle, and these braces are going to actually prevent it from coming out of its plane. To better illustrate this, if we come to backline analysis, I have already run it. And if we come to backline modes, we can here display the deformed shape for this first backline mode for this first combination. So basically, its behavior is as we described. Whenever this arc is being compressing, it would try to come out of its own plane, and that's why we are using these bracings. For the backline mode 1, this is what deform shape you obtain. If you choose the second backline mode or the third, you can easily take a look at how it deforms. Also, as you can see here, we have chosen two combinations for the analysis. The combinations for the backline analysis and also for the nonlinear analysis can be set in 3 different ways. We can manually insert the combinations with this option right here, or clicking in this blue arrow, we could actually ask the software to select for us the combinations according to the standard that we have selected for the job. Also, this third option right here is to let the software generate the combinations based on the results of the linear analysis. I think we're better going to see this when we take a look at the nonlinear. I mean the linear and nonlinear analysis. And for this, if we come back to the backline modes, we can see that for each combination, it has run a number of backline modes, and for them, it has obtained the critical load factor, which is displayed right here. Yeah, after the comma, this number at first is actually the backline mode, and this number right here would actually be the critical load factor. When we have many combinations, what we want the software to do, and what actually does, is it displays before each combination which is the mode which was resolved with the minimum critical load factor. And so in this case, both of them were in, well, this one was in the first mode and it was its value, and this one also had the same critical load factor. But when we have many combinations, we want the software to easily we want to easily see that minimal critical load factor to see what's the critic option that is actually maybe going to make this structure buckle. So as a result, we can assign the buckling coefficients automatically. So when we come to the results on the bars here in bars and buckling, we can take a look that the coefficients, the buckling coefficients have been assigned here in buckling X, Y, and XZ. We can see the coefficients have been assigned to the bars. Also, as we said, two of the results of the buckling analysis were automatic assign of the buckling coefficients, and also the percentage participation percentage. So here, right underneath the form shape, we can actually select the sensibility analysis participation, and for this mode, which was the critical one, we see displayed on screen and with colored with these colors that indicate which are the most participating ones. These brown ones, maybe if I rotate a little bit, you can better see them. These two brown bars are actually the ones that participate the most in the most critical mode. So they are the the most likely to the ones that we have to watch out. And here we see the other bars. Also, we can see the percentage of participation in the bracings, which is almost none. It's minimal. The participation of the bracings won't suffer from buckling. They are preventing the arc from buckling. So we said that OpenCS allows us to carry out this buckling analysis, as well as 3 cases of nonlinear analysis, which are only tension bars, which in this latest version actually has the option to also describe pre-stressing stress on these kinds of bars. Also, the second case of non-linear analysis is actually uplift at supports. And the third one would be plastic hinges. We previously had an elastic linear hardening, so one type of plastic hinges, and now we have the modified Ibarra Medina Crow-Winkler plastic hinge. So where are those in the software? Let me use another example. And when we come here to most recent files, actually the one that I'm looking for is this one. Okay, so in this model, these bars, these ties, and I'm going to hide everything else for you. So in this model, the length, the height of these reinforced concrete columns is actually approximately 30 meters in height, and this also, I'm going to hide everything else, but the the elements that I'm speaking of, which are the columns, which are actually the columns. These columns these top columns, and also maybe the parlins are going to buckle. So what we can also assign the buckling coefficients to reinforced concrete elements for this job, since these are the criticals that are most likely going to buckle. Those are the ones, even though all of them participate in intervene in the backline. Okay, if I activate only draw the elements that intervene, all of them intervene because they brace the the structure. But if we don't create these analysis groups, if we will probably waste the backlink modes. I mean, the backlink modes could get lost and being spent in bars that are not actually the subject of the analysis. So for this, we can create here analysis groups, which we have created for the columns and these parlins. And after the backline analysis, we can now check also in these reinforced concrete columns, the backline coefficient has been assigned. Okay, so for the nonlinearities that we were speaking of, which were these three that we spoke about, only tension bars, uplift at supports, and plastic hinges. Where are those? Like, how can we actually set those nonlinear behaviors? Well, if we describe these ties right here, we can see that they have been described using the behavior only tension. The behavior only tension means that for these bars, if the linear analysis comes as a result that they are actually compressed, in the nonlinear analysis, those bars won't participate. This second nonlinear analysis, which were the applet supports, you can select the elastic, the nonlinear behavior for the external fixities of the structure, as well as select a subgrade modulus for the shells. So this means that if one external fixity which we have described a spring factor for, it's actually being pulled uplift. This bar won't participate in the nonlinear analysis combination, and also true for the shells. If they uplift, then in the nonlinear analysis they won't be taken into consideration because they can only work in one way and one way only. So this bar, this tie that we described, the behavior only tension can be selected here. And as I said, as for this version, we can now set the pre-stressing stress on the bar. And to show you how those other are set, those other nonlinear cases, if we come here to the bottom of that column, we could actually select that the behavior of this external fixity has elastic behavior, and we can set here the spring factor, okay, and in which direction it works. That is also true for the shells. If we create a new shell, we can create that it has a subgrade modulus, and we can say that it can only have that subgrade modulus when it's actually compressed towards the ground. So those three linearities, three non-linearities, sorry, we can consult their results for the bars, just like we did in the previous version. In the previous models, we could come here to display the dialog diagram forces over the bars, okay, for this case. But I want to point out that if we choose here the nonlinear combinations, and actually the rolled and built up section still, for those ones that are only tension, the combinations, as you can see here and here, are nonlinear. Okay, so we can display nonlinear combinations. Let's say, for example, we can access the here the Excel force. We're going to amplify it a little bit, and we can see this is the axial force for the nonlinear combination. So some of the results that we can actually get from the software using those implemented standards that we saw before is actually to check the ULS checks and check the elements just in case any of them are wrong. So any element displayed in red would be one that doesn't verify all the checks, and one that is displayed in green will actually show you the these results. So for example, for any combination that actually has compression, or that is meant for compression, we will find that it uses the length of the backplane length that we have obtained from the backplane analysis. And for the results, sorry, I was clicking here on ULS checks, and you can here see that we can print a complete review report on each bar. This was reinforced concrete element, but let's choose also one that is steel. So you can see that according to the code that you have selected, you can obtain code checks not only for individual elements, but for the whole structure using here the reports, and also right by it are the drawings. You can also easily print some drawings. You can come here to create new drawings, and you can select from 3D structure drawing or foundation floor plan, for foundation layout, detailing of the columns, or column schedule. Here we could print, as an example, two of these drawings. If we click on detail all the drawings and we zoom in, we can take a look at how easy it was to create these outputs of the software, which could of course be maybe printed to the XF, DWG, and many other formats, just like the reports also can be exported to multiple formats. So another feature that I wanted to point out is actually the fire resistance. The fire resistance has some new features, which are the surface exposed to fire, choosing which checks for every bar, which surfaces are actually exposed to fire, which is going to determine the factor, the shape factor, and it's going to affect the coding. Also new in the past few versions was the intumescent paints by manufacturer. We have implemented the catalogs from manufacturer's paints, so you can automatically in a report get the coating, exact coating that you will have to apply to the bars. Here, that report has actually been improved in the past version. So let's take a look at that. When we come to the project general data, we find fire resistance. So if we click on check fire resistance, we can actually select the required resistance and the cover that we're going to use to protect those elements from the fire. And if we choose intumescent paints, these are the ones that have the catalog from manufacturers. If we click right here, we can access and actually download the ones that we're going to be using. So the software can access the data of the manufacturer's um, catalogs, and actually with the shape factor and the critical low temperature, it can obtain the thickness of the coating that we will have to apply. So when we actually run the calculate the stress and strains on the bars, we can then check the elements and those steel and timber sections for which we have selected the required resistance. They will display the fire situation results, which you can consult for this bar that's on screen. We can see that for this bar, it is almost in the limit of the fire resistance. It is 99%. Yeah, the number of exposed sites was 4. Now I'm going to show you where you can select that. And the shape factor and the critical temperature, this software has actually obtained those from the analysis. And the result is that for the intumescent paint that we actually used for this job, which was Hempel, one of Hempel's manufacturer's paint, we obtained that the thickness of the coating that we will have to be applying is actually 0.221 millimeters. Okay, so those are the results. The bars, whenever we come to bars and resistance and we click on a steel on a timber bar, we can select the exposed surfaces. So for example, this first option is all of them are exposed. This other option would be that the top wing is actually protected, and you can actually select this last option in which you can insert manually the shape factor and the number of exposed sides, as well as maybe in one part of the structure, maybe we have a different required resistance. For that, we can click here and configure the resistance, the required resistance specifically for each bar, and they can actually have different coding from the general data of the job. So the result, the end result of this is actually the fireproof report. So if we come here to reports, and actually we're going to select only the information that is fire resistance related, which is this. And also here in results of the bars, we have fireproof coating. So this is the report that has been improved, and that will actually show you directly each bar, what thickness of coating they need, what is its critical temperature, the number of exposed surfaces, the shape factor, and which type of element it is, whether it's a beam or a column. Of all of these reports, you can export to PDF or docs format or text format, multiple formats. And this is what I wanted to tell you about the fire resistance. So one last thing that I would like to show you, because, okay, the name of the title of the webinar was how to improve your BIM projects, right? So how does this all connect to BIM and services and BIM projects? Well, Cype 3D and most of our softwares are actually connected to our platform, BIMserver.center, which I'm going to show you in a minute. So if we Google BIMserver.center, and actually anyone can create an account with an email address and a password, you can easily access BIMserver.center when you can create your BIM projects and share them with anyone. Even though if they don't have a BIMserver.center account, they will be able to actually take a look at your BIM projects, exporting these structure, we and anyone could access the project information, where you can see that the file that is actually shared to BIMserver.center is an IFC file. And clicking on the visor, we could take a look at this BIMserver.center project. And when clicking in any element, since it's BIM, it will have the information. So this bar is this other column, for example, we can see it's rolled steel section. And so this is a way that you can actually improve your BIM projects, because Cype 3D is connected to this platform. So whenever you are on Cype 3D, you can log into your BIMserver.center account. And when you come to BIMserver.center and you click on share, well, you will first have to create the project. Okay, it can easily be created. When clicking here on link, you will be displayed this project selection, and you can create a new project, BIM project, okay, to which the information is going to be sent to. So when we click on BIMserver.center, and if the actual structure has some results for the forces, we can export those forces to the BIMserver.center and continue our workflow through other of our apps, which could be maybe Cype to design any type of connection, or be a BIM steel, which we're going to take a look in a minute. So Cype all of these connect through BIMserver.center. Like I said, your structure designed and analyzed could be shared to the BIMserver.center, and then you could have those results imported to either one of these other apps, Cype or BIM steel. So we're gonna open this job. Actually, I have imported the Cype 3D job to an BIM steel job, and we're gonna take a look at it. So BIM steel, like we said, Cype Connect is for the finite element analysis of connections. It can create connections between two steel elements, or between timber and steel elements, or two timber elements as well, using always steel connectors. This app uses finite element method, okay, and it uses, of course, for it OpenSys. And this last, the one that we're going to see right now, is actually BIM steel for the creation and maintenance of BIM models. So you can improve your BIM model even further from taking it to BIM steel, where you can actually create accessories. And of course, you can also there, if you have the Cype Connect, you can design any, and analyze those connections. And we're going to take a look at it, because it's better seen than told. So let's take a look at, here is BIM steel, okay. Here it is, sorry. And when we import it, we just have to connect it to the BIMserver.center. It will have come. And I have completed it a little bit to show you how you can improve your models by solving those connections, and inserting some accessories and some bars that weren't previously on the model. So whenever your model is sufficiently completed, you can share it back to BIMserver.center. And from this app, you can also do the detailing, generate the drawing detailing of the structure, and export them to manufacturers formats, DSTV and STEP, which are actually formats that manufacturers' machines read. So any cut that you have been done on any bar, or any specific drawing that you create, you can send directly to those other formats. Well, I think I've told you everything I wanted to tell you. I hope you have asked some questions on the chat. We'll be answering them all. But if you need any further information, please don't hesitate to contact us on Cype@Cype.com. It's been a pleasure to have you here today. Thank you so much for your assistance, and see you in the next webinar. Thank you.